Hi, everyone. Thank you for joining us and attending our our webinar on archiving any amount of content, keeping it accessible, and optimizing primary storage. My name is Adrian Herrera. I'm the Senior Director of Marketing at Caringo, and I have with me Robert Overzee.
Yes, thank you, Adrian. I'm Robert Overzee from ASG. I'm a product marketing manager, especially for the product called ASG Digital Archive, which is a huge success in the media and entertainment world. The one vertical we'll be covering today to illustrate the archiving of large volumes. So if there's one thing in the media and entertainment business that is important today, that is the volume search. There are many trends in this vertical, but the volumes have been exploding from 10 to 100 times. I mean, overall, the volumes are surging overall in the world, and 2 zettabytes were produced in 2012. 3.6 zettabytes have been produced in 2013. And if you ask me the question, what is a zettabyte? Well, a zettabyte is 1,000 exabytes. 1 exabyte is 1,000 petabytes. 1 petabyte is 1,000 terabytes. And a terabyte is roughly 13 years of MP3 music and 4.5 million JPEG pictures with a 10 megapixel camera. So what is special in this field here is that we're changing from SD to HD. HD we're there yet, through 3D, which is a kind of trend that's there to stay or to fade away. We'll see. And we're moving over to 4K for TV soon, and we've got customers already for 8K. Using 8K. When I talk to them, they say we're not going further than 8K for now, but what we'll be doing is moving from 24 frames per second to 48 frames per second. So all that is there to, to augment even more the need for volume, IT volumes. There are more projects because there are more buyers also of programs. 10 years ago, 15 years ago was pretty easy. You had NBC, ABC, CBS there to buy programs. Then you got Fox, USA Networks, HBO coming in the game. And now there's Netflix, Amazon, you name it. They all need programs. And all the post-production companies in this field, need to handle more productions. So do they need more storage for the primary storage to invest even more in this primary storage that's very expensive, or do they need to put less hours of programs? That's one of the big challenges they face. They also face technology change in this, not only the formats, all the formats they're handling, because that has been true for the last 50 years in their business, but also the speed of storage. How can I handle it? How often do I change one format to another, one tape format to another tape format? Etc. And I would say there, the fifth bullet point, which is not in there, and we'll see it on the next slide, is the change of working habits. Now, in this era of internet, fast bandwidth, instantaneous results, when you Google it, the producers of programs, and that's the next slide, the producers of the content want to see it right away, want to see it edited within hours. And that changes the workflow. And workflows are also changed by the need to have archives ready. Long time ago, you just had the edit, the ingest, the edit, the distribute, and the archive. Archive would be the last step of the production. You just put it away for a long time. Nowadays, the archive is in the middle of the workflows. If you edit, you might need an old piece of a feature film, because it's so much cheaper to reuse something else that has already been shot. If you distribute, you need an archived copy to show what you distributed, what aired, And if you ingest, and that's the first step normally, you need to make a copy into the archive, because 10 years ago you just put a blank tape in the camera and the camera would go back in the field. But now there's no such thing as blank tapes. What it is it's a flash cartridge that you ingest into the system and that you put back in the camera. So you don't have like a backup copy of what you just shot. So that cannot stay all in on the primary storage. So you need to prioritize storage by access performance requirements, because you don't need everything right away on the editing station. Sometimes with old stuff, you can understand it take 30 seconds to get there. So also you want to clean the primary storage with all the clutter. 20 years ago, an editing room was bits of films you would cut, paste together, and everything not used would end up on the ground. Well, that's not true anymore. You empty the primary storage from all that, but it might be valuable later on. It can be an actor that will be known in 10 years. It can be a blooper. It can be a bit that is necessary for the director's cut of the movie that will appear in 2 or 3 years. So that's also feeding a new need for workflows and the volume search. You need to protect the raw footage, and I'll have an example of a workflow later on that. The same example of that camera going back with the flash drives in there and not having a backup copy. You need raw footage to be protected. And also, you need to protect everything that has been produced. I'm thinking about our customer, National Film Board of Canada. Here, they need to protect everything that has been produced in Canada and that had taxpayers' money in there. And they're not there to protect it for 6 months. That's for decades to come, for 100 years to come. They must show what they've done and what the federal government paid for. And I would say the most important that the archive is there for most of our customers, and also that pays for the archive project in the first place, is to reuse whatever you shot, reuse it, whatever your data is, reuse it, repurpose it in some way, or remonetize it, or sell it. So, and there you've got the archive that is an active archive, and that's in the middle of all your workflows on a daily basis. And that everything there relies on a storage that needs to be solid, and that needs to be there so that we can count on it. There, Adrian, could you please explain what the challenges are from a storage point of view?
Yeah, of course. So all of the new occurrences in the media and entertainment industry that Robert covered are creating very interesting and very frustrating storage challenges across the industry as a whole. So just like new workflows are needed, new storage is needed. Traditional storage is just reaching its limits. Um, it comes in a few different varieties. The first is constrained expansion. So existing storage, primary storage, NASs, they're very siloed. A lot of them max out at the petabyte level, which just isn't, which just can't keep up with the scale that a lot of media and entertainment industries need and use. You know, they also come with tedious management to expand and maintain. So, when you do need to expand, a lot of the times they have constrained expansion. You need to expand, by a specific amount, or you need to do some form of manual content migration to the new hardware, and that takes time, that takes resources. Sometimes there's downtime for upgrades, and when you're providing a 24/7 operation for storage services, yeah, it's just unacceptable. And sometimes you need specialized storage staff. So in the media and entertainment industry, your business is content creation, content monetization. It's not storage management. So for a lot of organizations, those specialized storage management skills are difficult to find. We also see selective durability as an issue in the media and entertainment industry. So RAID just cannot scale. It becomes brittle with size. It's very difficult, if not impossible, to protect petabyte scale environments with RAID. RAID rebuild times take a long time. As the drive sizes grow, we're now 2 terabyte drives. We're going to increase that in the coming years. It's not uncommon for a 2 terabyte drive to take days to rebuild. And during that rebuild process, you really can't access that storage, or you should restrict access to that storage. So it's just unacceptable. And there are some backup and deduplication solutions out there in the market that are very expensive, sometimes even more expensive than just replicating the information itself. So we're seeing continuous protection of content as an issue in the media and entertainment space. And this also goes back to a point that Robert was saying, in the all digital workflow. Now, IT administrators within media and entertainment companies are really becoming like the archivists were, 15 to 20 years ago. So now it's up to them to maintain the gold copy. It's up to them to maintain the master copy, uh, and that is a new occurrence. So the way to do that is with highly scalable storage, and we'll show that further on in the presentation. And we're also seeing restricted access as being an issue. So Robert mentioned Netflix and a lot of new production companies and ways to watch movies and watch content in general. And you know, what we're seeing is cloud is really changing expectations in the market. Um, Not only end users, but also employees just expect to be able to get to content, to write to storage, um, really from wherever they are and from any device or application. And that is a limitation of traditional storage. So to do that with traditional storage, you need additional web servers, load balancers, you need additional infrastructure, which increases cost, increases complexity. Standard storage protocols like CIFS and NFS just are not web protocols. So it's very difficult for them to communicate over long distances of time over the public internet, if not possible. And we do see limited query and analysis being an issue. So let's say you have a content repository, you want to make that accessible to the public, and you want to make it easy for them to search for what they want for long tail content use cases. That's very difficult to do with traditional storage, and we're seeing a lot of media and entertainment companies struggle with that. But there is a solution. What we're going to show today is a solution from the application perspective, and then a solution from the storage infrastructure perspective. And for the application side, I'll pass it back to Robert.
Yeah, so the solution needs to be integrated in your workflow. It needs to be able to move data along for the storages you have into the Caringo storage we'll see later on. And you need to be able to move around data quickly and large amounts of it. That's why the tagline here of ASG Digital Archive is high performance file archiving software for large data volumes. Sometimes you've got one server that does the movement. What you don't want is the end user's machine to move the data, because that might freeze up his machine, and so he can't do his job. He can't perform it. And so here we can scale up very heavily, and that's why ASG Digital Archive, ADA, is such a success in the M&E world, is that we can grow from, I would say, 5 to 10 editor stations and the storage that goes with it, to customers that have 100, 200, 300 editors at the same time. So this is a software solution for archiving. It's flexible. You have several means to archive. One of it is manual, and we'll see that in the demo how it's done. You can do it automatically with a number of rules saying, okay, if the data on the primary storage is larger than, if it's older than, if it's of this type, or any combination of it than our archive. And I would say, along with manual, the very successful way of archiving is our third-party integration with the most famous MEMS, media asset management tools. So it's completely integrated in the mission critical or the daily application people use, and they don't even know there is ADA under it. But the only thing they know is that you just archive a documentary, a movie, a sports clip, a music video. They don't know where it's going, but they know it is archived, and they don't know it's on one copy in the object storage and two copies on tape on remote sites. Um, they don't know, they don't care, they know that data is taken care of. Data and metadata at the same time. We get it out of the third-party app. We can add some additional manual user info in there so that it's not lost. It's very cost effective because instead of putting more primary storage, which is extremely expensive, you can have here a tool that will push the data in several copies to the storage you want, cloud, object, tape, you name it. And we've been in the business for 20 years, storage business for 20 years now, so we know storage. We always interface with the best breeds of it, and we always archive in open and not proprietary formats. So if we're archiving to disk, we can copy the whole tree of directories onto the disk. So you, even if we aren't there, you can retrieve the information. Let's say that in 20 years we're not there anymore. If you have the storage, you can find the data. And also, if it goes to tape, TAR, LTFS, it's easy. You take a cartridge, send it to the other side of the world. There's a customer who will be able to read it. So that, in a nutshell, is the ASG Digital Archive. The other part of the solution is Castor. Adrian, can you tell us more about it?
Sure. So Castor, our tagline is scalable storage that works so you can focus on your business. So I'm not going to go into too much detail here. I'm really going to focus on the business value. If you do want to go do a deep dive in the technology, feel free to contact me after the webinar, and I can go ahead and give you a presentation. But since we have limited time, we really wanted to focus on the demo. That being said, what our storage software does, it virtualizes a pool of hardware resources, server resources, into a highly reliable, massively scalable storage solution. And it can handle any rate, volume, or flow of data. So it scales at the speed of your business. Our software deploys in minutes on the standard hardware of your choice. So if you're a Dell shop, if you're an HP shop, if you're a Supermicro shop, it doesn't really matter to us. Our software will run on all of those servers, and we can use any type of hard drive, SATA, SSD, whatever you have. We will go ahead and optimize. We'll pull all those resources and make it one massively scalable storage solution. This includes upgrading with no downtime or on-site support. Our focus is on simplicity, is on automation. So most of the major processes, if not all of the major processes, are automatically managed for you through the software layer. So that allows you to scale at the speed of your business, not just massive scale to the petabyte level, but also granular scale. So if you want to just add one drive at a time, you can go ahead and do that. So we also allow the optimization of resources by eliminating tedious manual tasks. So with a lot of traditional storage technologies, NAS, primary storage, there is a significant amount of manual effort when you expand. There's even more of a manual effort to forklift migration when you need to go to a completely different platform or the new version of the hardware. With us, all storage migration and namespace management is automatically managed. The software does that for you. We balance everything behind the scenes. This also allows you to easily add, retire, and replace hardware. So as as hardware it gets older, you can just press a button and take that out of the storage solution. Yeah, this also enables you to evolve with the market and your use cases. So just like you can retire hardware, you can add new hardware. So let's say today you're using 2 terabyte drives. 3 or 4 years down the road, you're going to use 10 terabyte, 20 terabyte drives, whatever is the most efficient, the most cost effective drive of the day. You can plug those in easily to existing chassis or add new chassis, and our storage software will automatically shift the content to those new resources, and then you can retire the old resources and take that out at your leisure. So it's you, if you can picture a river of hardware flowing under your data, not just today, but for the next for decades to come. You can do that with our software, and this is an important aspect for media and entertainment companies. Um, and all of the data lifecycle management is automatically managed via policies that's stored with the content itself. So we manage everything from expiration to from creation to expiration based upon policies. Um, so, for instance, data protection policies, we protect data in two different ways, through replication and through erasure coding. If you want to start a piece of content protected via replication, and replication simply means making exact copies. Let's say you want to make 3 copies when a piece of content is first created for a year, because that's the most likely when it's going to get access the most. Um, then you can shift to another protection scheme after that year called erasure coding, which essentially chops up the content into chunks with some parity information. So it uses less than just one additional replica, but it does give you those RAID level durabilities. Um, that can be automatically managed by the software. You don't need to manually specify that. You just specify that on write, or you specify a specific location within the storage system, and that'll, and when content goes there, it'll automatically be managed. And one of the other values we bring is we eliminate complexity through adaptability. So today we're going to be showing the active archive use case. Robert will walk you through a workflow, and then he'll walk you through a demo. But as Robert mentioned, primary storage is very expensive. Accessibility is definitely becoming an issue. So once you have that content on Castor, you can use that content for a number of additional use cases, and you can also use the existing storage infrastructure for a number of different use cases. You can give access to different applications. You can give access to your producers in the field to write storage or write content to it directly. Um, but a few other use cases that our storage is good for, that Castor is good for in the media and entertainment industry, are cold archive use cases. So we do have a technology called Darchive, which is adaptable power conservation, which actually spins down drives and reduces CPU utilization for cold archive use cases. So you get the same TCO as tape, but that content remains instantly accessible within milliseconds. And that's a standard feature in Castor. You can also use it for cloud storage use cases. So we do have an Amazon S3 API. We do support the major corporate identity management solutions, Active Directory, LDAP, PAM. We also support the cloud authentication approaches, token-based approaches. So you can also use Castor for cloud storage. And you can also use Castor for content delivery. So we do dynamic caching of hot content. So one of the unique things about Castor, and really object storage in general, is it's directly accessible over the web. So you can use Castor for content delivery. Um, and it's one storage solution. It's the same infrastructure you're using for all three of these use cases. But let's go ahead and do a deep dive on the active archive now, and Robert will walk us through a typical workflow in the media and entertainment space.
Yes, thank you, Adrian. Yeah, this is just one example of a workflow put in place by a customer. This is the typical infrastructure you would see at customer places here with video servers or one source of videos, whether it's a van, a satellite link, cameras, etc., or digitization. So once that is on the storage of these cameras, it very quickly goes into the primary storage here, where it's accessible by the video editing of workstations. And this is super important, that it doesn't reside solely on the primary storage, and that's very true for this customer for insurance reasons, because here the example I'm thinking of is a customer that is shooting or is in charge of the post-production for very large Hollywoodian productions. And so you just can't imagine how expensive it is to shoot a feature film from a very well-known saga. And so what they need to do is not just have it on the primary storage, but move it along to a secondary location, so to archive it. If you just can click, thank you. So before the people start editing here the workstation, on the workstations, these rushes, these dailies as they call it, you need to archive it in the deep archive, so you have a copy that is there for insurance reasons, but also if something goes wrong with the editing process, the color grading and all the type of FX. So here you've got the video servers which are for the broadcasting, and so typically here you would have an object storage, the ADA server, of course, who moves all the data along, and you could have everything in the deep archive castor. Sometimes they've got a near-line cheap disk archive also, where they would put it in for a couple of months, and they would make a couple of tapes so they can send it over to, for instance, the people who are producing the movie, the guys who have got the money in there, and so they get LTO tapes as well. So that is just one example of a workflow where everything is integrated and that is done automatically without the end users bothering to do stuff. This is an automatic one, and it's just one example of a workflow.
So here we are, the demo of ASG Digital Archive and Caringo Storage, Castor Object Storage it is. So before we go to the actual demo with the GUI interface, the end user interface, here we have a drawing of what the infrastructure is. So my machine with the GUI is one of these editing workstations, and here you've got the shared storage, of which I will take a file and archive it here to the Castor storage, where we'll have the data and the meta stored here. I will send it over to the CSN, and then it will spread over the nodes with a policy defined in the Castor system. So I will do one file, but it works for a lot of files, a lot of small files or big ones. And if you have a lot of volume here that needs to be archived, here the ADA server will not by itself take the data here from the shared storage all the way to the Castor, but it will be helped by a pool of data movers. So these machines will never have a hiccup. They will go on by being used by the editors. So to switch over to the ADA GUI here. So the ADA GUI is here with a number of project archives. So project archive is an archive that is defined by the storages on which it's spread. So when I archive, for instance, here in the DNA research, I can have one copy on cheap disk, one copy on tape, one copy in the cloud, and one copy in the Castor object storage. And it can be held in these different storages with different retention types. So without much further ado, here I've got the storages I can access. So on my computer or on the LAN. And here I've got the folders within the media files project archive I chose. So what I do is here, I just take one, drag and drop it in the folder I chose. Here you see that I've got a basket of all the archiving tasks I want to perform today or since the last time I archived. And so I just validate that basket to say, yes, I want to archive it. This file that's almost 16 megabit. Yes, I absolutely want to. And so these project archives have been defined by the administrator as well as these metadata requests. So there you've got metadata in the headers of the files, but also we can add here end user metadata. So here we see that there's one that's compulsory, director, and then you've got optional ones that's asset is it 4K and the video type. So we just enter that before archiving. So let's say Carpenter here. Is the asset 4K? No, it isn't. And what type of project or film is it? It's a short film here. So now I validate, and so that is processing. So here you see that created job because there can be a lot of people doing archiving, retrievals over the day. So there's a system handling jobs, and here you see that the data transfer started. So the data is actually moved from my storage here all the way to the archive. So here we see it. We see that the file is over there. Of course, for a same file, you can have different instances, different versions. So let's have a look at this version. So we see that there's some information here, such as the original location, the global path where it was, also the metadata in which we had in the header of the file, but also the metadata we entered. So the metadata and the data are both in Castor storage, and we see that it is here in there. So what we see is what storage it is on, and also an object ID. As Castor is an object storage, we need a handle, we need an ID, a token to access the file. So that's important. Archiving is important. More important is retrieval. So we've got several criteria we can work on. For instance, we can search here in the Qt folder for a film starting with 2 guns, for instance. Here, 2 guns. I want to run this search, and it found it. Here you see that I just searched on the name. That's common search. Common search, what we do in Windows. We can also search by metadata. So here I've got a lot of metadata here in the media project. I've got 3 end user metadata. So I'm gonna search on that. For instance, on is asset 4K? No, it's not 4K. So let's run. You want to run the search. It's gonna be searching the database, the ADA database. And so here I see a number of files, and I can just retrieve this one if I want to. So when you are in this folder, you can also easily retrieve to a location a file, as I can just drag and drop it here to my desktop. The retrieve is also a task, so I can retrieve one file or I can retrieve several files at the same time. So here it's created job, data transfer started, and it should bring back my file. And there it is. It's been brought back. So that is our demo for today. Thank you for watching.
So thank you, Robert, for walking us through that. That concludes the webinar. We'll now open it up for questions. If you have a question, just go ahead and type it into the dialog box in the right-hand column. I think we're slightly over time, so we're only going to take a few questions. If we don't answer yours, we will follow up with you directly. So with that, we'll go ahead and open it up. And I do have one question, and it is for you, Robert. And the question is, on what platforms does Ada run?
Ada runs on a number of platforms such as Windows, Linux, Mac OS, but for the server part is fading away because Apple is diminishing its support of it. So our customers having Mac OS platforms move to Linux now. But we also run on HPUX and AIX. But I would say the top three are Windows, Linux, and Mac OS. Of course, that for the server part, we run with our agent parts that are close to the storage on all flavors of Linux, Windows, because sometimes these might be on the on workstations.
I have another question, and it's for you again. What storages are supported by Ada?
Ooh, that's a long one. We have been in the business for 20 years, as I said. We've been working on backup solutions, so that's very close to the storage as well. And we've been working with all types of disks, all types of tape. Nowadays, tape pretty much means LTO 456, but we support also other types of tapes, libraries, and of course object storage, cloud storage. I mean, we've got a whole compatibility guide for people to see if we support their specific flavor of their storage. So that's available on our website.
And it looks like I have only one more question, and that's for me. It's how does Caringo compare to some of the open source solutions out in the market? And that's a good question. There are a number of open source solutions, and I think the allure of an open source solution is that it's free. You can go out and download it and use it immediately. Well, the truth is it's not free. You do need to have the necessary resources to be able to manage it. And you need a commitment to the DevOps process. So, I spoke about having specialized skill sets earlier for storage management. Open source solutions take even additional specialized skill sets, and a lot of them it just isn't coding and development. Sometimes they require some specialized database management skills. And you add supportability on top of that, and you'll find that those solutions really aren't free. In fact, they're a lot more expensive than a commercial product like Caringo. And if you ever do run into an issue, you can contact us directly. We offer 24/7 support, and we'll make sure you're taken care of. And that looks like all the questions, Robert. So for myself, I want to thank everyone for attending. Robert, thank you very much for presenting with me.
Thank you for having me.
And if anyone has any
And
did you want to say
you
something else?
go.
Oh, if anyone has any additional questions, you see the contact information for both Robert and myself. Feel free to contact us directly. Thank you very much for your time.
Thank you.